Hello everyone, welcome to the encounter. Do you actually offer customers any tooling to generate synthetic data, sample data, or a subset of data? I know you support VPC, you support fully managed inference engine, but if the customer has an on-prem H100 or H200 cluster, can they run the same inference engine with all the capabilities on-prem?
It's a great question.
But what can I do with the open source LoRaX project that's available on GitHub?
With LoRaX on GitHub, you can actually run that anywhere that you want.
One-liner definition and difference between TurboLora and LoRaX.
Usually fine-tuning is for quality. TurboLora allows you to fine-tune for speed and throughput.
Specifically on generative AI and LLMs, what exactly does Predibase offer? How do you play in this new ecosystem? Hello everyone, welcome to the encounter. Today we have a special guest, Devvret Rishi, the CEO of Predibase. Dev, excellent to have you on my show. Welcome.
Thank you so much for having me. Excited to be here.
Awesome. So let me get started with this question. So I know Predibase as a traditional AI company with the lineage from Uber, Harvard, Ludwig, and distributed training inference. So how did you keep up with the pace of generative AI and evolve into the space that you're currently in?
Yeah, it's an interesting story. So as you know, Predibase actually started just before this generative AI hype cycle. We started in 2021 as a platform to help users build deep learning models. It was built on top of an open source framework that one of my co-founders, Piero, built at Uber called Ludwig. And Ludwig was oftentimes called training wheels for deep learning. Our view was that the future was obviously going to be these transformer architecture, deep neural networks for every type of machine learning task. And that the main challenge that organizations had was building and serving these models was just really difficult today. So we built an entire no-code interface as well as a low-code SDK to make it easier for engineers to build deep learning models. And to be honest, Jenny, in 21 and 2022, we spent a lot of time convincing people deep learning matters. I had to explain why models like BERT and others were really compelling for tasks like doing text classification or sentiment analysis. And everything changed in 2023. Everybody started to care about deep learning models, but a very specific variant of them, which now are called large language models. Similar to the types of models people had trained in Predibase even in 21 and 22, but now scaled up 1 or 2 orders of magnitude. And so for us, we actually treated this as a company pivot, and we pivoted the entire company to be focused on generative AI workloads during the second half of last year. And we really took motivation from one of our favorite customer quotes, which is, generalized intelligence might be great, but I don't need my point of sale system to recite French poetry. And so we focused our company on how do we help organizations get task-specific models that are fine-tuned towards their data and then can really be served efficiently. And so that was really our journey, starting in 2021, built on top of frameworks that my co-founders had started authoring even in 2018 and 2019, right as deep learning had become kind of a major aspect, and then focusing fully on generative AI from there.
Excellent. So specifically on generative AI and LLMs, what exactly does Predibase offer? How do you play in this new ecosystem?
Definitely. Yeah, our view is that there's an arbitrage opportunity that exists in the market today. Every single customer that we see, usually has started experimenting with some commercial APIs for doing Gen AI, maybe OpenAI, Claude, or any of the other models that exist out there. And typically people start by prompt engineering. They try and write a few different prompts. And what I've heard from customers in there is that they're able to get to 70% very quickly. A few prompts, some engineering, some few shots, 70%, they're right there. But at a certain point, prompt engineering large models breaks down for when you actually want to go to production. Things like quality, speed, latency, ownership of models really ends up mattering. And so our view is that instead of having kind of these large prompt engineered models, people are going to have small task specific fine-tuned models that they put into production. That's really what our customers are doing today. And our platform is designed to help organizations take advantage of this arbitrage opportunity that exists in the market. And that arbitrage opportunity is you can actually get a smaller model to have higher quality and be cheaper and faster than a larger model. And the real trade-off you need to do to get all of those benefits is you just need to fine-tune and customize that model to your data and be able to serve it in-house. And those are the two things that our platform does. It allows you to easily fine-tune and customize your model towards your task and data, and then be able to serve it efficiently and at scale using the Predibase Inference engine, which we just did a GA launch for recently. And all of these factors are really just built on top of the open source projects we had initially authored, Ludwig for training, LoRaX for serving, and combines them into one end-to-end managed platform and service.
Perfect. So to summarize, it's essentially fine-tuning as a service and inference as a service.
Exactly. And the marriage of those two, which I think is actually really important. Because when you own both the fine-tuning and the serving side of the stack, you can do some really interesting things and build in some proprietary features that allow you to create a flywheel. As people fine-tune models, they actually can serve iteratively better models, and you can do unique things in the way you create those fine-tunes.
So let's focus on inference for a moment. So there are a lot of inference engines that can basically merge the weights that come from the fine-tuning job and merge them at runtime and start serving. For example, VLLM does that. Triton with TensorRT LLM can do that. And of course, then there is the generic TGI, which I'm not sure if it can merge the weights, the adapters with the base model, but there are quite a few inference engines that are capable of merging the fine-tuned weights and adapters with the base model and serve. So how does Predibase differ from those?
Definitely. Yeah. I think that, the biggest way that I think that actually differs from these frameworks is the Predibase inference engine is a product and infrastructure, and a lot of the other technologies are frameworks that people need to stitch together themselves. And so what does that actually mean? I think if you're using VLM, TGI, TensorRT LLM, you need to figure out what it looks like to build production serving. And I actually think that that is a really difficult challenge for engineering teams to do at scale, that most of them should not invest the team essentially that's required in order to do that. You need to build auto-scaling replicas to be able to handle traffic, different RPS patterns. You need to offer SLAs, deployment monitoring, and visibility. There's a lot essentially that goes into the step of how do you get a framework like VLM or TGI to go production ready. And I do think that that is the biggest delta that the Predibase inference engine has against, for example, open source VLM or TGI. A lot of our customers have started with something like VLM, but have ultimately decided that managing all of the infrastructure in-house is not something that is going to be sustainable and durable for them over time. With that said, there are a few more unique things that we do, even on the open source side, and then I'll talk a bit about the proprietary side. I think one of the things you're talking about is we're built on top of an open source serving framework we authored called LoRaX. We open sourced it at the end of last year. And LoRaX was the first serving framework to offer multi-LoRa inference. What multi-LoRa inference essentially allows you to do is it took advantage of the fact that when you do LoRa or parameter efficient fine-tuning, you only customize a small subset of the overall weights of the model, usually less than 1%. Now, when we open sourced this at the end of last year, the vast majority of the way people deployed fine-tuned models was every fine-tune was deployed on its own GPU. And we thought, obviously, that's going to be very inefficient at scale. There's no way people are going to do this. And so what we did was we created a framework where you can multiplex a single deployment to support multiple LoRa adapters. And the really cool thing about the way that we do this is that these adapters can be loaded into memory and then dynamically loaded or hot swapped directly at the time that a user is sending in a query. And so what this allows you to do is serve many different fine-tunes from a single base model. Now, over the last quarter and a half, some other frameworks have been increasing their level of multi-LoRa support, but LoRaX still maintains best-in-class LoRaX support in terms of like the type of, I'd say, feature richness it has for these types of cases. For example, supporting prefix caching and others for this, and the way that we do dynamic adapter scheduling and continuous batching. I think provides like the best in class when you scale out the number of LoRa's. So that is one big, I think, factor in terms of like where we are built. And then the last thing I'll say is we actually do something very unique that marries our training side with our serving side. And that feature is called TurboLora, a way to be able to get faster throughput using a purely software-based approach, not having to run on higher and higher GPUs. And I think that's also very unique to the Predibase engine. So just to summarize, I think that there's a lot of good open source frameworks that exist out there. The biggest difference that the Predibase inference engine gives you is that it's a fully managed, auto-scaling enabled, batteries included with the GPUs, SLAs compatible inside of your VPC or our cloud inference engine that just works out of the box. So no need to stitch this together and be on the hook for production serving yourself, but also marries the best-in-class multi-LoRa serving features we have in LoRaX and a proprietary feature that we haven't gotten too much detail into just yet, but I'm sure we will, called TurboLora.
Perfect. Yeah, we'll dive deeper into TurboLora, but coming to LoRaX. So, are you saying if a customer fine tunes, for example, 5.3.5, which is an SLM for sentiment analysis, for summarization, for classification, he would have the base model and some adapters and some weights that are derived from the fine tuning jobs. So, does LoRaX let the customer run the base model plus all these derivatives, which are the fine-tuned adapters, on the same GPU without the need to dedicate different GPUs for different tasks? Is that what LoRaX is all about?
That's exactly what LoRaX is all about. And I think that it's actually a game changer when it comes to how people think about deployments of fine-tuned models. It enables experiences you, frankly, probably wouldn't be able to have before. As one example, one of our customers is in the call center analytics space. So they have transcripts of different calls that are recorded. And they've actually trained 60 different adapters because they have 60 different signals that they're looking for in every single call. Just to make a few up, like was a competitor mentioned as one signal? Who was the primary stakeholder there? They have 60 different things that they're trying to parse out. Every single one is a fine-tuned adapter. And they serve all of these fine-tuned adapters on top of a single base open source model on top of a single GPU. And so all they need to do now is auto-scale with traffic. They don't need to deploy 60 different fine-tuned LLMs on 60 different GPUs. So I think that this is actually really powerful because it's a game changer in terms of the way that people can think about their fine-tuned models.
So I think this is going to be a game changer, not just for the inference engine, but also for the hyperscalers, where they need to optimize the GPU and deliver the best price performance ratio. So do you have customers who are actually offering model as a service or custom models as a service using LoRaX in production?
Yes, we definitely have customers they offer custom models as a service, usually wrapped in a vertical space, for example. But we have customers that are essentially using LoRaX, or actually all of our customers, I should say, are in production today. So when we work at a customer engagement, the success criteria for where they actually convert into an annual contract is when they have deployed a model that is in production. So all of our customers are in production, and they're all using our inference engine, which is built on top of LoRaX, and it's really kind of the managed service around that. And so, yeah, that's Converse is a good example of a customer that's serving 60 adapters, for example, in prod.
Wow. That's great. So Dave, one of the patterns that I'm seeing is a lot of customers are using multiple models. For example, they go to GPT-4o or Claude 3.5 for heavy lifting, for like structured output or doing some complex reasoning. And then they also rely on cheaper fine-tuned models for classification or sentiment analysis, or replacing a traditional NLP model with a fine-tuned model. And then they kind of aggregate the output and use that in their agentic workflow or in their RAG workflow. So is this a common pattern that you're seeing where customers are using federated LLMs, the most capable, which is commercial, and a fine-tuned open source model?
It is, but I actually think the pattern evolves a little bit over time. The way that I think about it is, and one of our customers has framed this the best. He basically has set up that what he'll do is he'll start every Gen AI project by just using maybe the most expensive model out there and putting it out into production. And his goal is to collect data, more or less. And so, using, for example, GPT-4 or Claude Sonnet, put out an experience, validate if this actually has user value. And even the most capable models, even with extensive prompt engineering, most of the time I don't hear customers say like, this works flawlessly, right? They say like, it's 70% and maybe 70% is good enough for me to go out into production. And then from what they are doing there is that they're actually chipping away at what workloads are in that model, that large model, to smaller task-specific models. And that starts with these easy, narrow tasks like classification, as one example. Like they want to go ahead and figure out which area they want to route certain queries over to. And so they're changing that from an OpenAI model to a small fine-tuned model. But actually what I think is interesting is I don't think it's only going to be these like really, really small tasks like classification that are going to migrate towards these small fine-tuned models. I think what you're going to see is people deploy with these large models because they have very good general reasoning capabilities. But they use that to collect data, and then they have a human-in-the-loop workflow where they correct where the model got things right and where the model got things wrong. And when they're collecting sufficient amounts of data, they're actually going to fine-tune a model to be able to do that. Because ultimately, the fine-tuned model is going to do even better than the large general-purpose model that's more expensive. And so that may be it may be a slightly larger, higher capacity open source model. But I think in building these agentic workflows, what I often see is, the 8 different steps that need to exist all start off with a large model. And then what you start to see is customers will chip away one at a time to bringing that into smaller and smaller SLMs.
Excellent. So one of the other use cases there that I'm seeing is the reliance of these larger models is primarily for multimodal AI, like structured data extraction from images and so on. And maybe a few months ago, the only multimodal capable models were GPT-4o and Claude. But today we have 5.3.5 Vision, we have Llama Vision, we have Pixtral from Mistral. So are you seeing customers fine-tuning these multimodal small language models with their custom data? Is that a common use case?
It's a timely question. We just released support for multimodal and visual language models in the last week in GA in our platform. So the reason we did it is because we've started to hear this from customers as well. So it's on the earlier side. The vast majority of our workloads are still fine-tuning on text tasks because I think those are in high production volumes today. But I actually see the need to fine-tune oftentimes be even more important in multimodal use cases because the types of things that you're trying to pick out from an image or the types of images you might even have access to tend to be even more bespoke. And so I'll say right now it's very early days for us. We've seen some customer interest and have just launched support for multimodal VLMs inside of our platform. And so I think over the next few months, I expect we're going to see customers go into production with those types of models as well.
Amazing. So one question that I have is, I know you support VPC, you support fully managed inference engine, but if the customer has an on-prem H100 or H200 cluster, can they run the same inference engine with all the capabilities on-prem?
Yeah, it's a good question. So I think the answer, like if I were to be very honest with you, the answer is in 2 parts. One part is like, yes, and the second part is, but it might be a little painful. And so what I mean by that is running Predibase on-prem is possible in the sense that we can deploy anywhere that you have a Kubernetes cluster set up. And so really like K80s is like our hard constraint for where Predibase can be set up. Now, running on-prem is always a little bit more complex than running inside of even a customer's virtual private cloud. It requires maintenance and sharing scripts where people in containers where people can go ahead and run this themselves. And so it's less of a technical constraint and more of actually an operational constraint. We've seen more than enough demand from our cloud customers and our VPC customers where we don't really look to do on-prem deals unless it's a very special case and setting. For example, a really compelling customer use case or the other. But from a technical level, our entire platform has been architected to be able to deploy anywhere that a customer might be running Kubernetes. And so it's possible to do so.
But what can I do with the open source LoRaX project that's available on GitHub?
With LoRaX on GitHub, you can actually run that anywhere that you want. And so with LoRaX, if you have LoRa adapters or fine-tuned models, you can go ahead and use it to be able to spin up your own inference engine and start to be able to run things like throughput benchmarks or start to run inference directly. And of course, if you don't have your own LoRa fine-tuned model, you can use our other open source project, Ludwig, to be able to help create those. But with LoRaX, you can actually spin up. You can think of it as potentially an alternative if you were used to VLM or TRTLM. If you want to go ahead and do multi-LoRa serving, I think it's a very powerful project to be able to start to use that right out of the box.
So can I go production grade with that, the open source project?
Yes, you can go production grade with the open source project and LoRaX. I think that it is very difficult to go ahead and build production serving, though, in full transparency. So the answer is yes. I think that the issues that I feel that users run into is not so much in getting an inference server up and running with that, but it really depends on how much your production serving matters. If you would say that hey, I just want an inference endpoint up and it doesn't need to auto scale, SLAs aren't that important, I'm okay with that having built out deployment monitoring visibility. It doesn't need to have multi-region replication. A number of the factors that end up mattering a lot once you actually have customers, for example, that are using your inference endpoints. I think LoRaX is a great place to be able to start. But oftentimes what we see is people build with an open source inference framework like LoRaX or VLM or one of the others, and it works until it doesn't. And what I mean by that is you're able to get something out of the door, the 80% solution, somewhat quickly, but then you realize that there's any number of reasons why you want a more managed serving solution, and those are kind of a lot of the infrastructure capabilities I was talking about before. Or you just realize that oftentimes building full serving requires a team of ML engineers, and that's not something that you want to maintain in-house, and that's where people make this shift towards managed solutions. But certainly there are people in the LoRaX community that are using LoRaX today in production. It just depends on the scale and size of the application that they're looking to do.
Perfect. So coming back to the multi-adapter serving and merging this on the fly at runtime, do you also optimize at the CUDA kernel level, or is it just the inference engine? How much of CUDA is involved in this overall optimization pipeline?
Yeah, we have written our own, we do use custom CUDA kernels for this. And in particular, the custom CUDA kernels are required, I think when you're switching, when you've loaded a lot of these adapters into GPU memory and you need to be able to dynamically load them, one question we get is what is the cost, the latency hit, or anything else, or throughput cost to be able to do all this dynamic adapter switching? And so we have written custom CUDA kernels that really optimize the way you do the mapmul, for example, in any of these kind of inference calls, and especially when you're doing the dynamic adapter loading. And so we have had to go into that level, kind of on the optimization side. And in addition to kind of the custom CUDA kernels, we've also built in a few other types of capabilities, like an adapter exchange scheduler, heterogeneous continuous batching, and multi-GPU and tensor parallelism. This has all been kind of some of the key features that we needed to build to make sure that doing all of this multi-LoRa serving is performant. Because ultimately, it's great if you can switch adapters, but if you had to incur some significant latency or throughput costs each time, then I think it wouldn't be a tenable solution. So that's really where those optimizations came into play.
So it means currently the Predibase inference engine powered by LoRaX runs only on CUDA and NVIDIA. For example, I cannot use TPUs, or I cannot use the Neuron SDK running on Inferentia.
It's a great question. So today, out of the box, the Predibase inference engine is optimized for NVIDIA. We actually are working on supports for AMD, but we also have custom support already built in and are piloting with customers today. And then we all have a couple of other hardware companies that we're in partnership talks with to be able to enable on their chipset too. So there's obviously a little bit of work that goes into making sure we're compatible on every new customer's chipset. But AMD is something that we've prioritized initially as getting our inference engine working, and it's something that we actually have available inside the platform today. And the next set of cards, I think, will be coming very soon too.
Got it. So talking about fine-tuning and inference. So one technique is the SFT, LoRa, and generating these differential weights that can be merged. But how about quantization? Do you also support quantization that can run on lower GPUs with lesser memory, lower-end GPUs?
Definitely. Yeah, definitely. And we do this for two reasons. One of them is when we deploy inside of a customer VPC. The great thing about Predibase Cloud is we have access to A100s, H100s, in early access, we can get access to H200s. We have access to all of these high-end GPUs, and we can slice them as people need to scale up or down. But for some of our sensitive customers where it has to deploy in their VPC, getting access to H100s on demand inside of AWS today is still a little bit of a challenge. And so that means you need to be able to deploy on smaller and smaller GPUs, like A10Gs as an example, where some of our customers are actually deployed in production on. And so quantization is important to be able to reduce the memory footprint of models to be able to run on those types of cards. And so we definitely have support for quantization on that side. But there's another reason quantization is actually helpful, which is to be able to also increase inference throughput, even on like a given similar card. And so we've done a lot of work to enable FP8 quantization as an example that is really optimized for cards like even the higher end cards. And what we've seen is, using FP8, you're able to increase your throughput. And then using a feature like TurboLora, you're also able to increase your throughput. So when you marry these two, you can really get best in class throughput on fine-tuned models. And so quantization has been important both for the GPU availability, but also to speed up inference.
Great. So coming to fine tuning, one of the challenges is data. Obviously, getting the right level of clean data is very difficult these days. So are you seeing synthetic data as a service becoming more and more popular before fine tuning is kicked off? And do you actually offer customers any tooling to generate synthetic data based on their sample data or a subset of data?
Yeah, first of all, I'll just say that I think calling out the data as a challenge is a great call out. I said that there's an arbitrage opportunity that exists in the market. You can get better quality at faster speeds and lower costs. And you should ask what's the catch, and the catch is you customize and tailor it to your data. That is like essentially the upfront requirement to be able to do it. So I definitely recognize that's a piece. With respect to synthetic data, I think that this has become an extremely common workflow. And the way synthetic data, I think, works most effectively is using the thing that we talked about with agentic workflows previously, which is you put a model in production that's a large model, either production or internal testing, and use it to start collecting real prod data. But you don't just use the synthetic data. You use that as a starting point, and then you do some human-in-the-loop annotations and modifications of that. So you try and look at where did the model get things right and wrong, make corrections, and that allows you to train a smaller model that's even better than that larger model was able to do. And the majority of the data is synthetic, and the corrections are what are human developed. And so that's the workflow that I see most commonly. And we think this helps you build sort of a data flywheel in terms of like how this gets created. With respect to your question on does Predibase have any capabilities around synthetic data? We do. Specifically solve the cold start problem. So some of our customers are like, great, I want these benefits, but I don't have labeled data. I can give you 10, 20, 30 examples, but usually we see fine-tuning be beneficial once you have hundreds or thousands. And so what we actually built in the platform is a synthetic data augmentation technique, where you can start with as few as 10 examples and then choose how many rows you want to upsample to. You choose upsample to 100 or 1,000 or more. And we actually do some really clever things in the way that we generate this synthetic data. So we don't just say, go to large LLM and say, generate 20 more examples like this. Instead, we take an approach, a mixture of agents approach, where we break down every single synthetic query into 8 or 9 different prompts. We ask the model to generate multiple candidates and then critique the candidates, generate more diversity, and so forth. We create this pipeline that you would never be able to put into production because it requires too many LLM calls. But it's really good for creating high quality synthetic training data. And you can actually use this directly in the Predibase platform today. It exists as a feature in GA.
Perfect. So finally, how do you see the evolution of agents and agentic workflows, and how is that relevant to Predibase and SLMs?
Definitely. I think the really good thing about agentic workflows is that it exploits the fact that models are not that excellent at more complex tasks one shot. So what agentic workflows do is they break down a task into a series of modeling calls. For example, somebody comes in and says, I want to book a flight. Okay, let's figure out, or book a trip. Let's figure out which flight they want to be able to book on, what are the options, what are the dates. And that's like one LLM call. It's like figure out the options. The second LLM call is figure out which one's the best. And the third LLM call is figure out which hotels. And the fourth one is figure out which price is optimized. So it takes it like the reason agentic workflows are powerful are because they break down a task into multiple subcomponents. And what we see from chain of thought reasoning is that models do really well in kind of stitching these pieces together. The difficulty with agentic workflows is that requires making many LLM calls, and that feels very expensive and slow, I think, oftentimes. And so I actually think agentic workflows are a natural marriage of both SLMs and LoRaX. Because I think the future of where I see agentic workflows go is you're never going to chain together 15 really expensive and very slow prompts to some really general purpose LLM and put that into like a production application that's feeding high throughput traffic. Instead, the way I see this happening is you're going to fine tune small adapters for every single one of those different types of tasks. Those adapters are going to be best in class on the individual part of the agentic workflow that they're optimized for, ticket routing or booking or anything else along those lines. And then the real trick is going to be making sure you can serve all of those adapters on top of one base model so that you can do it efficiently and cheaply. And so, of course, that's where LoRaX comes in. And I think, the future of building these types of workflows is, it's really clear in my mind. It's going to be small fine-tuned adapters for every component, all served on top of a single base model using an inference engine like LoRaX.
Absolutely. So it's not one model rules all. It's basically a collection of models that will drive the agentic workflows. So, Dev, before we conclude, one-liner definition and difference between TurboLora and LoRaX.
Definitely. One sentence on TurboLora. Usually fine-tuning is for quality. TurboLora allows you to fine-tune for speed and throughput. So at the same time as quality. So what TurboLora gets you is models that are anywhere from 50% to 3x faster without a degradation in quality. And it's just using a proprietary way that we do the fine-tuning. So if you want the fastest fine-tuned LLMs that also can get served on LoRaX, check out TurboLora. It's a very, very cool and innovative feature.
Great discussion, a lot of technical details, and thanks so much for joining me today and sharing your vision for Predibase and how you're currently implementing optimized accelerated inference. Thank you.
You got it, Johnny. Great to be here. Thanks for having me.